Hey everyone, welcome to CNCG Ahmedabad and welcome to CNCF Project Tours. CNCF Project Tours, this is the third episode of CNCF Project Tours, and we have an awesome project today, Kyverno, and we have an awesome speakers to share about Kyverno. We have Rashi and Swastik from InfraCloud. They will share their experience and their knowledge regarding Kyverno. And from the team of CNCF Ahmedabad, I'm Shivlal Sharma and Sandeep here, Sandeep Kanabar. Okay, so over to you, Rashi.
Thanks, Sandeep. So, thank you guys for giving us the opportunity to be here. And we are really excited to be presenting about the Kyverno over here. And with me, I have my co speaker, Swastik, and we are from InfraCloud Technologies. And yeah, just waiting for more and more people to join. So, in a couple of minutes, we can start.
You guys are free to chat. You can share your introduction in the chat section.
Or you can also introduce yourself by speaking if that is what you prefer.
So I think we can start with at least our introductions. Meanwhile, people are joining in still. So I work at InfraCloud Technologies as a customer success engineer, and I majorly work for Loft Labs as customer support engineer for the product of V clusters and V cluster platform. And here I am here to speak about the Kyverno, and let's see what magic it brings to the table. And we still have Swastik, who is from InfraCloud. So to Swastik now to introduction.
Hi everyone, my name is Swastik Gaur. I am a product engineering intern at InfraCloud. I am also a LFX mentee, a former LFX mentee at Kyverno, and I at InfraCloud. I majorly work with Brancher and an open source project called Parallels. So that was about me, and for my work with Kyverno, majorly involves dealing with policies and uh, researching about them and submitting proposals for them as well.
I think we can start with the session, Shivlal. Can we start with the session?
Yes. We have a audience now. We can start with the
Okay,
session.
sure. Can you guys please confirm if you are able to see the screen?
Yeah, it is visible.
Okay. Okay, so hello everyone, and as we have amazing sessions for CNCG Ahmedabad, so this part 3 is all about security, about how you're implementing security in cloud native, and I think that except for Kyverno, there is nothing good enough that we can start for this session. So this session is going to be about around Kyverno, how Kyverno is actually leading in the cloud native spaces, what are the security breaches that have already caused problem to a lot of people, and with Kyverno, what changes it has brought into the implementation. Also, since we are going to start with just introductory part in the initial, and then we have Swastik, who is going to take us to the live demo, where he's going to present us with the live demo of 3 policies, and we are going to have lots of fun over here. So I just request everyone to be to stay till the end. Yes. Yes. Okay, so guys, before we actually get into the session, I want to know how many of you think that you can actually spell Kyverno correctly, or you have spelled it correctly before this time, because it has always been the thing that people don't know how to spell this particular word. Okay, this is actually a very tricky word to spell if you are actually looking it for the very first time. So it is spelled as Kyverno, and it is like a policy engine. We are going to see about it in more depth in some more time. So for the today's agenda, we have the introduction to Kyverno, we have security in cloud native, we have policies in Kubernetes, and we are also going to see the types of Kyverno policies, and we are also going to see the demos around it and some fun learnings. So basically, just like Kyverno is nothing but a Greek word. So if you know, it means govern. Now, since we all are here in India, we all know that there is a government who is ruling us. Okay. So it is like there is a higher power who is going to rule us, and so that we all stay on the same path, we all stay on the same stone, and there are consistencies in the laws, in every orders, in all regulations. That is the reason why the government stays over there. Now security is something that starts right from the apartments that you live in. There is a security guard at the basements, and till the security continues to the Kyverno policies in Kubernetes. So security is everywhere around you. Okay, so you just name it and you will see the security everywhere. Now the thing comes is like the security implementation in every aspect of the world is different, and this actually, which means govern, this is a Kyverno. So it is going to rule everything around Kubernetes. It is going to help you maintain the government, like the rules, the regulations, the laws, what to follow, what not to follow, what should be standardized practices in the world of Kubernetes. So Kyverno is a Kubernetes native policy engine. And now if you are thinking that it understands some other language, and you have to learn some other language to actually learn more about it, or just to write the policies, you're wrong. You just need to know the YAML language, that's it. And because these policies are made in such a way that it makes the user, it gives the user the ability to read and write the policies easily. So it's just the YAML language. Although we have some other projects that come under Kyverno, where there is also support for JSON as well. But in this, we are completely going to focus around the YAML language. And then it also acts as an admission controller. Now I'm not sure like how many people over here are actually much into DevOps or Kubernetes. So I'll start with actually what is an admission controller. So admission, just think about admission controller as an gatekeeper or a security guard who just checks about which person should enter your building premises and which one should not enter your building premises. Like there is some rules, there are some laws that are applied, and if you fit into that particular laws, then only you should be allowed to go somewhere. So this is the same thing, that is the same methodology that Kyverno implies in the world of Kubernetes. So it helps in generating policies, it helps in generating the policy reports, it helps you to maintain standardizations throughout your implementations. So we let's see what it is. Now, as I just explained a few minutes back, that security is very important in cloud native, because it is everywhere. Okay. Now, if you're thinking about particularly infrastructure, like the IT departments, you must have seen in the newspapers or in the blogs or everywhere that many of the time security breaches happen. And if security is actually compromised, it is going to impact your organization's vision, it's going to impact your organization's name, because there are multiple customers who are using your product, and if they feel that their data or their sensitive data is not safe with this particular company, they will start rethinking, because something the sensitive data is something that no one wants to compromise about. Okay, so maintaining security is very, very important. Now what happens if you don't maintain the security in cloud native? Because the surface there are multiple nowadays we are actually seeing that, right? Nothing is being followed in a monolithic way. Everything is getting deployed in a microservice based architectures. Okay, now what happens is that in microservice based architecture there is not a single team who is doing everything, like the deployments, your testing, your developments. Nothing is being handled by one single person. There are multiple teams, like for front end it's different, for back end it's different. Everyone is using the different teams. And also with these things, it happens that the testing person did not test something properly, and then there was some vulnerabilities which actually came along, and it went to the deployment. So there are multiple places that you have to actually be aware, where can your things go wrong, where are the more places where your attackers can attack your applications and everything. There is also like the dynamic and short-lived workloads. Then as we discussed, that if you don't maintain proper security, is going to create zero trust and access control. There are regulatory compliances, and then there is software supply chain and risks. So now the very good example I would like to share with you is it's the recent one. In 2021 there was one thing that a company was using Docker images. Okay, and due to something, because of the testing was not done properly, or there were no security implied in it, it happened that attackers put some malicious code into that particular Docker image, and then that Docker image was being downloaded over 20 million times. Now just imagine the amount of people who have used that malicious code into their system. They have compromised their data, they have compromised their sensitive data. Also the company who has given it out has faced the a lack of trust, and they must have lost so many of their customers, right? So to avoid all of this, it's important to maintain the security. And now, like, we are here to learn about policies. Kyverno is a policy engine. Okay, so before we actually learn about what is this Kyverno policy engine in Kubernetes, let's first understand why policies even matter in real worlds. Okay, policies are everywhere. There are government policies, there are policies in your organizations, your HR policies. You must have heard this word like so many times. But this is just to make sure that each and every person who is in that particular group or team or even a country, everywhere, they stand on the same level. Okay, so that there should not be any sort of inconsistencies, so that everyone follows the same plan, everyone follows the same code of conduct, or everything should be standardized. That's the whole motive of implementing policies. And now the same motive is what Kyverno has brought into the Kubernetes to imply everything. So if you see the policies in Kubernetes, it is firstly, there are multiple applications that are actually hosted on Kubernetes. Okay, since Kubernetes is one such CNCF project which is getting so much boom, because it is ensuring your application is having zero downtime, like you're always having the high availability and everything. So no people want their applications to go down. They should have high scalability, and everything should be really good. So Kubernetes is the only go-to option for them. Now when it comes to Kubernetes, there are compliance and governance policies like ISO, then GDPR, and there are many of other such policies or benchmarks that are set by some higher authorities or higher standards, that if your application is being hosted on Kubernetes, you have to follow such guidelines so that it is considered a secured one. Okay, then there are some security enforcements that you need to take care of. And then there are some problems like resource management. Now, like, if you are working in one particular organization, or if your team is sharing one particular Kubernetes cluster, in that, to maintain a good level of isolation, or to say, to maintain a good level of security into different projects or different people of the team, it is necessary that you manage your resources efficiently. And then there is access control. Now you'll say, like, in Kubernetes there is already RBAC. Okay, so why do you need the policies like Kyverno? This RBAC is only restricted to particular permissions, but there are some aspects where security needs to be implied even beyond the access control. So we have some demos where Swastik will be covering these things in detail, but just to give you some idea, sometimes it happens that when we are building the Docker images, we use the images from the non-trusted sources, like not the Docker hub or something, but there are some other sources as well. Okay, and you don't know about where these images are coming from or what malicious code these images carry. And then it happens that developers of one particular organization use them in their implementation and use in their product. And that's how the activity malicious activities have entered the organization. Now the data breaches, security breaches, everything starts coming up. So it is very very necessary that you scan your images before you use. So that is background scanning, and image scanning is one type of policy. Then it happens that some users should be restricted, like there are particular users who should be using only the particular labels. If the cluster is they are using is production cluster, or it's the dev cluster, they should be having some sort of classification in them. So these are the small type of policies. So the policies can be namespace scope, or it can be cluster scope policies as well. So that is why the policies in Kubernetes is very very important. Now, just if you see in this picture, actually, I have tried to show you two flows. Okay, the first one is where Kyverno doesn't come into the picture, and what happens, how a API request is traveled. And in the next one, we are going to see what happens if you have Kyverno implementation in the middle, and how the things flow in that. So the first one is without the Kyverno implementation. So this is the user who is going to send a Kubernetes API server request. Now, as we talked sometime before, RBAC is the only type of check that is done without Kyverno, and if it fails, it's it's going to handle it in its own way. But if it passes, then it's of course going to execute the particular request. Now your request could be like create some pods, create some config maps, create some services, and that things are going to get created. Nowhere here you have implemented any type of security or any type of standardized, like, hey, my team is a development team and I want everyone to use particular labels, or I want every developer to use particular resource configurations only in this particular cluster. So you have not implemented any such type of thing over here. And this is just the basic examples of where and why the policies come into the picture. And now whatever your pods or services are over here, that state is going to get stored into the etcd. Now this is the implementation without Kyverno. Now let's see how it is with Kyverno in place. So now you can see this pink colored box that is added over here. So the user is going to send a request, Kubernetes API server request, and then that is initially going to go to the Kyverno admission controller. Now I told you that it's going to act like a gatekeeper or a security. So it's going to be there to take all the requests. It's going to do two things. First, it's going to see if whatever policy that admin has written, that request which is coming from this user, does it fall into the proper criteria of whatever is mentioned in the policy. If it falls, then the request is going to go to the execution part, where the pod services, config maps, everything is going to get created, and then it is going to get stored in your etcd. But in case if it doesn't happen the way the request is coming, but it doesn't have the proper resource configurations, or say it doesn't have the proper labels that you have written in your policies, then the request is going to violate the policy. Then Kyverno has two options: either validate it or mutate it. So validate is like it's going to see if it falls in the criteria. If it not falls, then it will either block it, or if you have written it in such a way that it should mutate the policies, it will make changes to the particular configuration so that it can get further accepted. So these are the two things that will happen if it doesn't fall into the criteria of policies. So that is the flow of how it works. Now I'll just stop here for a while, because since this is the flow that comes for the API server request, now to just deep dive into it more further, I will hand over to Swastik, where he will show you about how exactly this requests are handled with Kyverno in place. Swastik?
Let me just,
Yes.
yeah, let me just share my screen. So this is the official documentation of Kyverno. Is my screen visible? Hello.
Yes, yes.
Okay. So this is the official documentation of Kyverno. So what happens is Kubernetes has of, two components called known as webhooks and controllers. So think of webhooks as a bridge between your API server and a separate software, and controllers are, like the name suggests, like they are controllers that control like the state of your cluster or your uh, number of deployments or something like that. And how Kyverno internally functions is whenever there are matching resources created that matches the policy. So Kyverno has a webhook engine, which is like here you can see it. Here's the Kyverno engine. What it does internally is first your request goes to webhook controller, and after that, webhook controller, if your policy is validating, it works as an overlay syntax matching, and if it is mutating, it just works as pure overlay. Think of it something similar to Customize, uh, which is a Kubernetes-native project. And uh, if the policy is mutating, it works similar to kubectl patch command. And if the policy is validating, then and if the resource doesn't match, it's just logs of policy violation. If it is in audit mode, which we will see I will show you in policy that I have wrote. If it is in audit enforce mode, the resource won't be created at all. So here you can see there are different components with Kyverno. So what so Kyverno can also do cleanups as well. So it can also clean up your resources, pods, or deployments. So for that, we have a cleanup controller. Kyverno can also create reports of policy violation or the resource that has been created. So through report controller, background controller helps you, like let's say you have already created an existing resource and now you want to modify your policy. So at that time, background controller comes into places, and after that, Kyverno has added few or more features like verifying images and policy exceptions. Policy exceptions are like the what resource should should not be compulsory to abide by this policy. So, like as the name suggests, policy exceptions. So that was a brief overview of how Kyverno actually works as a dynamic admission controller. So over to Rashi again.
Thanks, Swastik. So I'll again share the screen.
Let me just stop sharing.
Yes, can someone please confirm if you are able to see the screen?
Yeah.
Okay, so since this was the top level overview of where Kyverno resides and how the request flows from a very top level, and Swastik showed us the internal workings about how Kyverno and what other details are over there. So we'll move to the next slides now. So that as we discussed, there are types of Kyverno policies, different type of Kyverno policies. Okay, so firstly, it is the validating policy. You must have already heard about it. Validating policy is nothing but is going to check like, hey, like, yeah, I'm a developer. I maintain a developers team, and I have written a policy that will make sure that my team is following a particular resource configuration for CPU, for memory. It at the same time it's using particular annotations. It's also making use of some labels, or it's use everyone, like 5 people are there in my team, and all 5 people are using the same and standard format. And if you are not following that format, then the validation will fail. Now, depending upon it, there are different ways how it can be handled. So it can either block or it can be mutated. Then comes the mutation policy. Like, the mutation is something that there are going to happen some changes, and these changes are like, if say if one of the developer fails to maintain such configuration, then you just do some changes in the configuration so that it can be accepted further into the execution of the request further. And then there are cleanup policies which are very recently introduced, so it will be really nice to watch about how they are being cleaning up the resources and all the configuration. And then there are also generating policies. So these are the basic type of policies that majorly all organizations use, and we'll see demos around it. And here are like a few projects, like it's the CNCF incubating project, right? The Kyverno is a CNCF incubating project, but under that there are multiple projects that actually come, like Kyverno JSON. As we discussed, YAML is the basic language, but it also extends to JSON formats as well. Then there is Chainsaw and Kyverno auth server. So Swastik is going to take us through all of this and give us some overview around that. And also we will start with our demos. So over to you, Swastik.
Is my screen visible?
Yes, yes.
Okay. Just a minute. Okay. Yeah. So here's my new Vim setup, and here's a validating policy example. So what in a validating policy, what happens is you have to specify, like in a regular Kubernetes manifest file, you actually first specify specs, and in a similar fashion, you even here you need to specify specs of your validating policy. Well, what validating policy does is actually checks for the overlay syntax. If it matches, if the resource that is created matches the overlay syntax, it passes. If not, it reports a policy violation. So here I have given the name of the policy as check teams, and resource that I'm trying to match is pod. So whenever the pod is created, this policy should be activated, and this policy should check if the pod is complying with the policy. So here's the validate policy, validate condition. Another validate condition, we have failure action and force. So what it means is if the policy violation happens, then the resource should not be created. And if the failure action was audit, that means it will just report a policy violation and the resource will still be created. And under that, we are giving a message label team is required. And for pattern, we are actually matching what we are actually matching the YAML struct that should be there in the pod that we are actually trying to create. For that, we are using there should be a label under the metadata called teams. So and we have two examples for that. First pod actually has a label team engineering, and second pod has a label does not have a label team. It has a label app web. So let's just use this test this policy. Okay. First of all, let's just apply this policy. So we have applied the policy, and I have, for that matter of fact, I've already installed the Kyverno. Kyverno can be installed as a standalone, and it can be also be installed in a high availability mode by setting multiple replicas. So let me actually show you all the deployments that are there along with Kyverno. So here see we have Kyverno admission controller. We have which contains handles validating admission webhooks and mutating the admission webhooks. We also have background controller which checks if policy has been modified and checks for the resources based on that. We have cleanup controller. We have report controller. And let's also check if the policy has been applied or not. Yeah, policy has been applied, and let's apply the two pods that we have. As you can see, the pod 1 has been created and it is running fine. Now let's try to create pod 2. So yeah, so here you can see it has reported a policy violation, which says label team is required. So the policy violation has been reported by the Kyverno, and since the failure action is in enforce mode, the pod won't be created. And similarly for mutating policy, since we cannot actually check if mutating policy has been applied correctly or not, since it's just mutating. So for the simplicity, what I have added is so what it is doing is just like I said, it works as an kubectl patch command. So it basically is an overlay similar to customize. So what we are doing is in the spec section and under the container, uh, whatever the container is, we are setting these environment variables as proxies on that. So let's try and apply these. So mutating policy has been applied to the cluster as well. Now let's see the pod.yaml file. So it is just a basic pod file which runs Nginx container and a Redis database. So let's try to apply this pod and let's see what actually happens. Or even better, let me actually show you the Kyverno CLI. So through Kyverno CLI, you can actually just test it in a sandbox type of environment, and it will just report you if the policy has failed, passed, or without actually creating the resources. So this is one of the cool features that Kyverno also offers. So Kyverno apply F and we have mutating and the resource name which we are applying is I'm applying it against. Let's just apply through kubectl. I guess it is not installed in my system. Oh, the earlier policy is not being affected by that. So earlier, what happened was the reason for pod not being applied was the policy that we applied earlier was still in effect in the with the policy that actually required labels. So let's try to apply the pod.yaml file again. So yeah, pod.yaml has been created, and let's actually check if it has been modified or mutated or not. Yeah, as you can see, the proxies has been assigned to the pod, and uh, mutating policy is actually working pretty well with the creation of pods. And for my final policy, which is generating resources for generating resources, this one is like I made this at my LFX mentorship with Kyverno. So this was one of the first policy that I actually wrote for Kyverno, since it was really useful and easy to make. So it is really helpful for your cost optimization as well. Even Adidas actually uses the this a policy simulator to this for their internal server. So what this policy is, it creates a VPA in the recommender mode whenever there is a deployment and pod created. So so it is so syntax for this is we have generate field, and under the generate field we are kind of passing like whole of YAML structure for a VPA that the structure for VPA that should be there when a pod or deployment has been created. So we have kind pod of vertical pod autoscaler, API version autoscaling kits.io/v1, and here's the regex for name. Basically, we are just saying whatever the name of the pod or deployment is, add VPA in front of that. We have namespace for that. For basically, yeah, it is saying is whatever the pod or deployment namespace there, deploy the VPA in the same namespace as well. And in the data specification, so VPA YAML of a VPA also has a data specification section. We have a target reference, which is uh, targets what pods or deployment to actually observe by the VPA that is attached to it. So we are attaching it to the pod or deployment that has been created, and we are doing it in a recommender mode. So in the recommender mode, we set update mode to off. So let's try this policy. Uh, Okay, and let me also show you that VPA and metric servers are already installed on the system. Yeah. So VPA recommender and VPA admission controller and VPA updater are also installed on the system. And for this policy to work, you also need to set cluster role and cluster role bindings so that Kyverno is able to make or get or delete the VPA resource, since it does by default it doesn't have permission to do that. So you have to apply cluster role binding to for Kyverno to actually be able to work with VPA recommender. Let's apply the policy. Uh, let's also delete the previously generated policy. Okay, now we just have a generate VPA recommender policy. and we have a pod, which is just again a basic Nginx container, running a basic Nginx container with some resources, requests and limits. So let's also apply it. Get so the deployment Nginx deployment has been created. Now let's see if the VPA or recommenders has been generated or not. For that, we can just run kubectl get VPA all. So yeah, as you can see, the VPA has been created for Nginx deployments, and since we created three replicas, so three Nginx deployment VPAs has been created. So yeah, so that was it the uh, for the demos for policies. So so these are really basic policies. For more advanced ones, you can actually check at the yeah for for the advanced policy one, you can actually go to their GitHub as well and even contribute to that. Let me show you once. Yeah. This is the repo that actually contains all of the policies that are there that have been recommended, or that are that can be used directly, or that are industry standard, I should say. Uh, there are thousands and thousands of policies for that, and also I would like to cover a few more projects, such as like Rashi told, there's a chainsaw. So what chainsaw is? It is a basically E2E testing platform made specifically for Kyverno. Under the hood, it actually uses assertion trees. What are assertion trees? Assertion trees are nothing but uh, checks your incoming request uh, based on your already provided information or a policy that you have applied. So so it is kind of similar to E2E testing, and Kyverno also has a similar tool called Kyverno Test, which is a CLI, like I told you earlier. Kyverno also a CLI tool, which can also be used for testing. You provided a policy, you provided a resource, and you can also provide. After that, you also need to provide if the policy needs to pass or fail according to the resource and policy, and you basically get a result according to that. And there is also a project that was developed by my friend Sanskar. So Kyverno NY plugin. So NY you may have known as an L7 proxy, and so what it basically does is you have an incoming request, and that incoming request goes to NY proxy, and then NY proxy uh, gives it to Kyverno auth server, and Kyverno auth server decides based on the policies that we have applied that the request should go to uh, the deployment or not. Like a policy example policy for auth server can be certain users should not be able to access books endpoint, or there should be a header associated with the request, and something and similar to that, similar in the similar fashion uh, that can be used to enforce fine-grained security control. And we also have Kyverno JSON. Uh, like Rashi told you, Kyverno now has some flexibility to check for JSON payloads. So earlier we actually Kyverno was also only Kubernetes or YAML native, but now they have extended their functionality. So I actually also already had that open. Yeah, here it is. So yeah, so Kyverno now extend the functionality for scanning or validating or even mutating your JSON payloads. So it can be anything: your Terraform files, your Docker files, cloud configurations, or any other JSON request as a whole. So that was it for my side. I guess we can move to quizzes and Q&A.
Yep. So thanks, Rashi and Swastik. We have a few questions here from Rishabh. One question is from Rishabh is that what if Kyverno is deployed in two namespaces? Is it namespace scoped or policies will be applied in Kubernetes object in namespace where Kyverno is?
So basically, policies in Kyverno can be applied on the fine grained namespace. So no matter where have you want what namespace you have applied Kyverno, your policies can work throughout your cluster, throughout your namespace, uh, or it basically gives you a fine grained control over your cluster resources and security as a whole.
Okay, I hope that answers Rishabh's question. There is one more question. I think Rashi already answered that. So, yep, I think we don't have much questions right now. You can unmute yourself and answer the questions. If anyone wants to, you can raise your hand and mute yourself.
Yeah, so should I share the screen?
Yep, you can.
Okay. Okay, so guys, what we have learned, it would actually multiply your understanding if you just try to answer some questions around it. It will really boost your confidence in learning new technologies. So, anyone would like to answer this one? Because for the last, I guess, 40 to 45 minutes, we have learned about this. Anyone of you would like to answer what is Kyverno primarily used for in Kubernetes? No matter if you are very new to this technology or if you have just started with DevOps or everything, but if you want to answer, please feel free to.
Yeah. So Vishnu has
Uh,
actually answered the question correctly.
we have Samir
Okay.
here who wants
Okay.
to unmute and share
Okay.
his learning. Just give me a minute. Samir?
So,
Samir, you are now in a presenter mode. You can unmute yourself and share. I think Samir is on mute. But okay, Samir shared his understanding here. in the Q&A. So he says, based on his limited understanding, is Kyverno behind the scene is a wrapper on mutating webhook plus admission webhook? Does it provide other extra things apart from this?
Yeah. So, like that's a really great question, Samir. To be really honest. So basically, you are right. Kubernetes has a validating admission webhooks and mutating admission webhooks. Uh, for them to actually function, you actually require controllers. For each, yeah, that means for each web, or either it is validating or mutating, you will actually require a separate controller for the same. And for that purpose, Kyverno actually comes into picture. So what a like I said, what a webhook is. It is kind of a bridge between your API server and a separate source of software or a separate piece of software. And that separate piece of software is a controller that you actually deploy for controlling the flow of your uh, for admissions uh, and for and that at that point Kyverno comes into play. So whenever you have a resource creation that matches your webhooks, so it goes to controller and checks if that it should be what we can actually do with it, and these uh, according to the provided instructions, those instructions are called policies that we actually write. So Kyverno is actually that controller that helps us by so that we actually don't have to make separate controller for every separate webhook. I hope that answers your question, Samir.
Okay. Do we have any other
Let
questions? No, we don't have any other questions. So, yep, I think we can wrap up our session here. Uh, Thank you, Rashi. Thank you, Swastik, for joining us for this episode 3, sharing your experience and your knowledge for the Q&A. And you guys can connect with Rashi and Swastik onto their socials for any further questions and further discussions. Right, we will share the recording on our official YouTube channel, or also the CNCF's official YouTube channel. The our recordings still are on pending for CNCF's official YouTube channel due to the long queue. So it will be uploaded soon on the CNCF's official channel. We are in the discussion with the backend team. So, yep. Thanks
That
everyone.
is
Thanks
really
for
bad
joining.
at processing recordings. I really hate this platform because of this reason.
Yeah. Okay. Thanks everyone. I'm stopping the recording.
Yes, thank